Dr. Kannan.
Yeah, good morning. Good morning.
Good morning. So, first of all, apologies for making you to wait and some interesting presentation and discussions. So, thank you again for coming online. So, we run short of time as a request. So, if you can, maybe one question we can entertain probably. Okay. So, if you can have your presentation for about 9 minutes. I know that you have been working hard.
That is the toughest thing.
It's a lifetime work for you.
Yeah.
So we have one or two questions on that actually. Okay. Yeah. Thank you very much.
Right, sir.
Thank you. Yeah, I think
Is it?
I suppose you need to open up the file first and share the screen. It's unlike.
Share option is not coming. Na?
I know. Yeah. Can you please go to the presentation mode?
Yeah. Is it okay now, sir?
Yeah, it's very great, and we can start now. Okay. Yeah.
Yeah.
Thank you. Yeah. I'm not into.
Very
I'm
good
not
morning
into.
to all the distinguished all the distinguished participants in the workshop. At the outset, my apologies. I wanted to join personally, but then I couldn't make it. Now the virtual medium at least has given me an opportunity to talk to you on this occasion. Okay, I am given the very difficult task of winding up in 9 minutes. So that the slide deck is not set for that. But still, I'll skip many of them and then try to do justice to what I want to convey today. In fact, it is the perspective, an R&D perspective on the corrosion challenges that the refining industry is facing. And
Kannan, sorry to bother you. Can you make it a full screen at your side?
yeah, it is on full screen only.
From the display setting, please go to display setting.
Play.
On the top left side, second one. It's a display setting. You could next. Yeah. Can you make it full screen? Duplicate.
Okay, is it okay now?
Great now. You
Yeah.
can also hide it. The one the bottom you see there. There's something. Yeah. Oh.
Oh, it's gone.
Okay. You can please go back again.
Ignore. Yeah.
Is it okay now, sir?
Thank you. Yeah. Thank you.
Yeah. So we are the largest refiners in the country, faced with the challenge of operating a refinery as old as 120 years. As you can see, we have a refinery at Digboy, which was installed in 1901, and the latest one being 2016. So that is the kind of diverse infrastructure that we need to maintain. At the same time, we also have the largest length of liquid pipelines, underground buried pipelines, which is almost 20,000 kilometers running crisscross across the country. As you all know, the crude corrosivity, it depends mainly on the organic acids and the amount of sulfur that is present along with the water and other inorganic salts that comes with the crude, which poses a challenge for the downstream oil refining industry, either in transportation through the pipelines or during the processing and refineries. So you will all appreciate that that there is a drastic change in the crude chemistry, especially for the crude composition for which the infrastructure was designed and put in place, and the currently prevailing composition. So this is mainly with respect to the high total acid number of the crudes as well as high sulfur. The transportability in the existing pipeline suffers because of the very high sulfur crude that we tend to transport in the recent times. So the question here is the compatibility of the existing materials for these kind of change in the chemistry of the crude. And also on the other side, you see there are a lot of bottom of the barrel technologies that are demanded to derive value out of each drop of the crude oil that we process, which results in terms of the increased temperature, pressure, and the severity of processing in the refinery infrastructure. And on the other side, there is a regulatory compliance which we need to meet. Right now it is at 10 ppm, and tomorrow definitely it's going to go down to less than 10 ppm, demanding a very deep desulfurization of most of the products that we make. Okay, now this is a general refinery process. For some of you who are already initiated into the refining process will appreciate that there are two workhorses in a refinery, the fluidized catalytic cracking unit and the hydrocracker unit, which operate, one of them, the hydrocracker unit operates in presence of a very high pressure, high temperature hydrogen and catalytic environment. We try to crack the high molecular heavy molecules of the hydrocarbon. Whereas on the fluidized catalytic cracker, where the catalyst itself acts as a fluid, so it's a highly erosive particle, so giving rise to multitude of problems to the infrastructure. Okay, so as far as asset integrity management of a refinery of the magnitude of IOC with the very widespread 100 odd years of asset, 100 years old asset is concerned, there are systems that are to be put in place to accomplish that. Unit level inspection, as you know, every refinery has its own inspection team which takes care of the assets then and there itself, for the failures or for repair and all that. But otherwise, an R&D like IOC R&D is required more from the point of view of conducting a detailed failure investigation and giving a suggestive action, remedial action for not the failure not to recur. In addition to that, there are some long-term activities that are taken up at R&D center, like corrosion susceptibility evaluation, kinetics evaluation, then modeling, and coming up with advanced non-destructive testing tools, doing a fitness for purpose assessment for any given service, and then remaining life assessment, developing the methodologies and implementing it for operating the old infrastructure, the refineries and all that. So I will be just giving you just an overview of each of these activity quickly. The failure cases, yes, in service as well as project stage failures we face. There are n number of failures that we face. So operating period of 100 years has definitely provided a lot of failure compendium, which is very handy with respect to any upcoming refinery as well as in the existing refineries as well. So this is something which I tend to show in every conference, where the impact of the failure. On the right hand side, what you see is a pressure vessel which had taken the toll of around 7 people in a refinery, in our own refinery. Sad to say, but that is the implication of any failure that you can expect. On the left hand side, you see a crude pipeline whose leakage has inundated a huge area of a standing crop with crude oil. On the left hand side bottom, what you see is a simple erosion failure caused the complete decimation of the asset in no time. Okay, so that is the kind of impact a failure poses, a failure results in any operating refinery. So this is a collage of many of the failure cases that we have dealt with, and over the period of time we have learned all these failures and corrective actions have been put in place. One of them is the hydrogen blistering that we see here on the middle left-hand side middle part of the slide, which is a result of our pumping more and more of high sulfur crude in our cross-country pipeline. So you can see here the lamination present in the pipeline has really given a place for the hydrogen to accumulate and result in kind of bulge. On the left-hand side top, what you see is the naphthenic acid corrosion. So with more and more of high tan crude that we process, so most of these furnace bends are susceptible to high tan corrosivity, due to which you can see a small kind of leak of the process fluid. So these are I won't go and get into many of them, because each of these failure has resulted in a kind of a lessons learned for us. And that is the first-hand experience of that particular metallurgy to that particular operating condition. So which is really a very good compendium. It serves as a very good kind of a reference for many of our currently faced issues in refineries. The next one is the condition monitoring systems. So we have some of the online condition monitoring systems in place, which is continuously providing me the idea of the wastage of the material as it happens. So the field signature monitoring method, what I have shown on the right hand side, as well as the PermaSense, this is prevalent right now in many of the Indian refineries. So these are continuously monitoring the thickness loss that is happening wherever they are installed, and giving a forewarning of the rate of material wastage as well as the corrective actions that are needed to be taken. And the left or bottom, what you see is the pipeline. The earlier speaker also touched upon the microbial influenced corrosion, which is more prevalent in many of the pipeline systems. which use basically seawater in hydrotest and all that, and subsequently there are some low levels accumulation of water, stagnant condition results, and results in the microbial induced corrosion. So we have developed, our own DNA profiling, toolkit which we have given to our pipeline division. So on a periodic basis, they evaluate the muck that is collected during the cleaning for the presence of MIC, and a very preventive kind of action is taken by dosing biocides into such lines where MIC is prevalent. On the offline and online non-destructive test systems, yes, many of the systems that have come up worldwide and every worldwide refinery is using, we have also adopted. But more, I would like to stress on some of the NDT which are very, very critical, which are very difficult to source from the service provider point of view. So we have taken a conscious call of developing our own tool. One such tool is the instrumented pipeline inspection gauge. So this is completely in-house developed, and right now, as I speak, the entire 22,000 kilometers of pipeline, liquid pipeline that we have, is using only our indigenously developed IPIG tools. And these tools serve the multiple purposes of, one is to find out the wastage that is happening, internal or external corrosion in the pipeline. At the same time, the more prevalent the pilferage situation that is faced in many of the pipeline sections also is pointed out by this inspection. And now we are multiplying these tools and trying to use it much more frequency than what OSD specified. On the left hand side, what you see is the crawler, the laser, the EMAT and ECT, a composite NDT crawler. So this is a joint development with IIT Madras, where this crawler can give me the health of the reformer tubes, which are basically centrifugally cast, high nickel alloys, and they suffer from mid-wall fissuring. So this development is again a joint development with IIT Madras, where these crawlers have been developed. The prototypes have been evaluated. Now we have started using this for our own in-house inspection. Of course, the drone-based inspection is coming up in a big way. All the oil refineries are using the drone inspection as well as robotic crawlers to have an online assessment of their assets without calling for any shutdown. Now, the important part is the design adequacy in altered service. This alteration of service is something that happens on an everyday basis. A very simple example is high sulfur-bearing crude, transporting it in an existing pipeline. So we did the due diligence of the compatibility of my existing pipeline systems to transfer a very high H2S crude in the line. So hydrogen cracking is what we had evaluated, and then we took a very conscious call of limiting the H2S limits as far as the pumpability of such crude oils is concerned. And in the earlier speaker, one of the participants had asked for the ethanol blended fuel transportation. So that was again a very conscious due diligence that happened at IOCL, and we are the first one to pump the ethanol blended gasoline in a pipeline, cross-country pipeline. And this has been taken up after again a similar study of the effect of ethanol on the weldments, especially what Dr. Sridhar mentioned about the stress corrosion cracking aspects. So far up to E20, 20% ethanol in gasoline, we have done the stress corrosion studies, and for most of the pipelines, the weldments are compatible to take 20% ethanol. As he rightly pointed out, the amount of water, oxygen, the dissolved oxygen, as well as the methanol impurity is what contributes to most of these stress corrosion cracking failures of the weldments in pipelines. Then the kinetics modeling, yes, this was again a joint work with Honeywell, and these kind of models have been developed for processing high TAN crude and to see the effect of the TAN number along with the sulfur content in terms of the processing temperature, wall shear stresses that are prevalent in any given pipeline. The corrosion models have been developed, and these models have been put to use by IOC in doing the blend optimization. So we don't directly process the high TAN crude. We are taking up to 8 to 10% of high TAN crude in our overall crude inventory. And right now, as I speak, there are around 250 crudes that IOCL has in its basket. So when we are trying to blend the high TAN crude, we try to limit the TAN values as per the model prediction, and also have a sufficient sulfur as a protective layer. So these kind of conscious calls can be taken if one has a one does a corrosion kinetic models, and these models can help us really in limiting our operations to some extent and preventing the corrosion a priori. Then the corrosion inhibitors are again a very cost-inducive proposition to have a continuous inhibition in the cross-country pipeline. So we have developed our own indigenous inhibitors, and we are using these inhibitors both for our product pipelines as well as crude oil pipelines. The fitness for purpose assessment, in some cases where we see crack or crack-like linear defects, so we are left with no option but to continue with these, for want of immediate replacement. So to buy time, there has to be some kind of a conscious decision making in continuing the equipment for a given period till the replacements are arranged. So we are using this engineering critical assessment for this purpose, using the failure assessment diagram concept as well as the VS7910 and API 579 codes, and these codes have been successfully used in many applications like LPG storage sphere. The leg support cracks we had, multi-layered hydrogen bullet also had some cracks. There was a blistering the LPG water vessel. So in all these cases, we had used this approach of FFP assessment using the engineering critical assessment approach. And on the RLA side, as I said, because of our aging of our refineries, there are many infrastructure which are running beyond 30 years. So we have a very elaborate stress rupture, creep rupture test laboratory, using which we are meticulously carrying out the life assessment procedures based on the the creep life, expanded creep life, and recommendations are given to the refineries about continuing to use those heater tubes or any high temperature tubes that are suffering from creep. So finally, the areas of concern in the present system is the adequacy and effectiveness of the current corrosion management system. There are continuous upgradation that is taking place. However, systemic changes, these are required to make it much more effective. We are aware of that. And on the other side, there is also a demand for reduction of maintenance costs associated with the inspection process. So more and more automation is what we are moving into. As far as the changed energy scenario is concerned, there are a separate set of challenges that are emerging for the entire refining industry. So one is the digitalization and real-time monitoring requirements, where corrosion itself has to be used as a process parameter to facilitate proactive maintenance. To some extent, IIoT-based systems are in place in some of our refineries, but still a lot more needs to be done. And what is emerging now is the integration of the biorefineries with our existing conventional refineries. So where you have a different set of corrosion processes that are happening. So what needs to be understood is the effect of such co-processing of the vegetable oils or the pyrolysis oils have to be clearly understood, and its impact on the existing materials of construction of refinery also needs to be understood, so that in future when there is an integration happening between the biorefining, bio oil processing in the conventional processing, so one can be prepared to to take care of the assets. On the other hand, of pipeline transportation, someone had asked also to the earlier speaker about the transportability of the hydrogen spiked fuels. Of course, this is a problem which the entire world is seized of, and some of the European countries have already advanced in qualifying some of the transportation pipelines for hydrogen transportation. So we in our India, we have initiated a joint industry program under the leadership of CST, to really look at pumping the hydrogen blends along with CNG in the existing gas pipelines. And this program will pave way in coming up with specifications and acceptance of the stakeholders like the governing the basically the OISD and the PNG are the statutory bodies also to come on board to allow the existing gas pipelines to take in some proportion of hydrogen in it. The last one is a crude to chemical transformation. So every refinery is now looking at staying profitable by having a flexibility of switching between the fuels and chemicals as per the need. And this again is going to pose a lot of challenge, because when you are trying to convert crude to chemical, the operating conditions are much severe than what you can expect in a conventional fuel-based refinery.
Kannan?
Yeah, this is the last slide, sir.
Yeah, thank you very much.
Okay, so I already said, there are as far as the metallic materials are concerned, yes, a lot of knowledge, exists, and we can extend this knowledge for all those challenges which I said, which are upcoming challenges for refinery. But there is a separate set of non-compatible elastomeric components. Today as we speak, no fuel is pure. So we have, ethanol blended in gasoline. We have diesel blended in, we have methanol blended in diesel. So we have DME blended in LPG. So that is one way of arriving at doing a decarbonization of the entire fuel spectrum. But then that opens up a separate set of understanding that needs to be developed as far as the compatibility of the elastomeric components that goes into many of these processing units, be it be a simple storage system or transportation system or systems that are prevalent in the domestic application and all that. So finally, I would say that a lot of challenges are upcoming challenges, and these challenges definitely have to be met with the conscious R&D efforts. Thank you very much.
Okay, so thank you, Dr. Kannan. It's really very comprehensive, presentation of various problems, corrosion problems faced by a typical refinery. And I know that it's a very interesting topic. I think maybe one question that we can ask some of you.
Yes, sir.
Yeah, and please.
It came to my notice. Myself is Santosh Haprao, NTPC. So it came to my notice that IOCL has taken some corrective measures in handling firefighting corrosion.
In
Firefighting corrosion.
Okay. I will, Dr. The thing is that it is related to the corrosion mitigation of the pipelines involved in firefighting. I mean those pipelines. So what kind of mitigation measures that you normally employ in those pipelines where you use for firefighting?
I don't know whether I could really answer that. In the firefighting lines, see, one is the most prevalent is the MIC, because of stagnant conditions. So you need to have really the avoid the stagnant conditions in the firefighting line as far as the internal corrosion is concerned. On the external corrosion, yes, there are a lot of coatings which we are allowed to. I don't see anything more than that in firefighting systems.
Yeah, I agree with you. Yeah. So I know it's very interesting topic. There are many people who like to ask you questions. And maybe I ask the organizer to share the email ID of yours. We are okay with that. So that they can contact you offline. So let's give a big hand to the speaker. Thank you, Dr. Kannan. On behalf of organizers and for the participant on my behalf, thank you very much. Okay. Over to organizers.
Ladies and gentlemen, we can now break for the tea break and we can reconvene in another 10 minutes for the next session.